Hello everybody, today we're going to talk about radicals. So first off, our team is myself, Rodrigo Barragan, with ID number A01285013.
My name is Mauricio Diaz with the student tag as A01285126.
And I'm Kevin Cavazos with A012851 and 64.
So I hope you get some help here and understand us. Thank you. Hello mates, today we're going to talk about how to take the area and perimeter of a rectangle when radicals are present. Does anyone know the formula to take the area of a rectangle?
Me.
Yes.
It's area equals base times height.
Perfect.
Thank you.
So, now with the formula, let's start with the radicals. We know that 45 has no perfect square root, so we're going to take it out. We're going to take it out as a 9 and a 5, because 9 times 5 equals 45. Now, 9 has a perfect square root, so we're going to take it out like 3 and 5.
Hey,
now,
Professor,
80.
I have
Yes.
a question.
Yes.
Why is the 5 inside the square root?
Well, because this one has no square root, so it must be left inside.
Oh.
Now 80. 80 will leave as 16 and 5, because 5 times 16 is 80. Now, we take out the square root of 16, which is 4. So now we have common indexes and radicals and everything. So now we can multiply them. So 3 times 4 is 12, and 5 times 5 is 25. 25 has a perfect square root. So then we take it out as 5, and 12 times 5 equals 60. So we know that the area is 60. Thank you.
Okay, so now we're going to see the perimeter of the shape. Does anybody here know the formula for perimeter?
Yes. 2 times A plus 2 times B.
Perfect.
Professor.
Yes?
in the class by sandwich.
No, get out. So now, 45 doesn't have a perfect square root, so we're going to take it out as 9 and 5. 9 does have a perfect square root, so we take it out as 3. 5 doesn't, so we leave it inside. 80 doesn't have a perfect square root, so we take it in as 16 times 5. 16 does have a perfect square root, so we take it out as 4. 5 doesn't. Now that we have the same indexes, okay, so we're going to multiply them. 3 times 2 is 6 plus square root of 5. 4 times 2 is 8 plus square root of 5. So now that we have them multiplied, we add them. And like that, we know that the perimeter of the shape is 14 plus square root of 5.
Now we are going to talk about multiplication with radicals and with different indexes. First, we have a cubic root of 27. That's the same as saying 3 times 3 times 3, so we are going to pass it down as a 3. Now we have a square root of 81. That's directly 9 times 9, so we are going to pass it down as a 9. And a for root of 266 is like saying 4 times 4 times 4 times 4, and we're going to pass it down as a 4. Now we are going to do the multiplication like we always do. 3 times 9, 27, times 4, it's... Does somebody knows the answer?
Me. It's 108.
Nice. So our answer is 108.
Hello again, now we're going to solve another problem with radicals. First off, we need to clear them. So now, let's say that the 32 is equal to doing this. 2 times 2 times 2 times 2 times 2. So we know that it will go as 2. Now, the rule always when we have an x5 and 5, it just clears, so it goes as 2. Here, 64 is equal to doing 4 times 4 times 4. So, it goes out as a 4, and the x, 6 minus 3, x3. Now, here, the final one, we go at 25 has a square root, which is 5 times 5. So it goes out at 5. And x, since we have a 2 here, x goes as 2. Now we can multiply them. 2 times 4, 8. And x3, x4. Now we multiply it by 5x squared. This equals 8 times 5, 40, and 4 plus 2, x6. Leaving the final answer to be 40x6. Thank you.
So now that we have this problem, we have the fourth root of 81x to the fourth power. So this is basically like saying 3 times 3 times 3 times 3. So we take it out as a 3x, and we multiply it. The square root of 121 is 11. We take it out as 11, and we cancel the x squared, so it's only x. Then we have the cubic root of 512. This is basically like saying 8 times 8 times 8. So we take it out as an 8. Now that we have them simplified, we can now multiply them. So 3 times 11 is 33, x squared times 8. So now we have to multiply 33 x squared times 8. It is 264 x squared. So now we're going to see some of the common mistakes that people do when simplifying radicals. So when we are simplifying this, we know that the square root of 16 is 4. But since here x to the third power doesn't have a perfect square root, so we will have to leave something inside. We will have to leave x inside, but sometimes people forget when they don't have a perfect square root to put the radical.
Another common mistake is when you have two radicals, yes, adding each other, but one of them is a different index, like this one. This is a square root and this is a cubic root. So for this, you have to convert them into the same index, or just in a real number. First this one. The square root of 64 is automatically 8, and the cubic root of 27 is like saying 3 times 3 times 3, so you're going to pass it down as a 3. Now you can add them, so because they are both real numbers. So the answer to this problem is 11.